Vanakkam. In our previous video, we calculated the effective resistance of this unbalanced bridge using a shortcut method. Now, in this video, we are going to use a general method, that is, we are going to apply some potential difference between these 2 points. Let it be 100 volts for our convenience, and we are going to apply nodal analysis, that is Kirchhoff's current law. Kirchhoff's current law at these 2 nodes, and we are going to calculate, let this point be C and this node be D, and let the potential at this point be VC and the potential be VD here. So, by the method of nodal analysis, we are going to calculate the potential at C, potential at D, and we are going to calculate the current here. Let it be IC, and also the current through this 10 ohm resistance, let it be ID. So, by calculating these 2 currents, IC plus ID will give the net current or total current through the circuit. As we know the total potential applied, we can calculate the resistance, effective resistance or effective, which will be equal to the potential and the total current IC plus ID. Advantages of this method is, we can calculate the potential at this node C, and we can calculate the potential at the node D. We can calculate the current through this resistor, current through this resistor, current through this resistor also, or if it is a galvanometer, we can calculate the current through this resistor, current through this one, current through this, net current. So, by this nodal analysis method, we can calculate potential, potential difference, current through any branch, and effective resistance of the circuit. Applying Kirchhoff's current law at node C, we can write this equation, that is VC minus potential here is 100 volts, 100 by the resistance 10 ohm plus current through this resistor will be VC minus VD by the resistance 5 ohm plus VC minus 0. Here the potential is 0. Therefore, VC minus 0 by the resistance 5 will be equal to 0. If you multiply this term by 50 divided by 10, then 5 times, that is 5 VC minus 500 plus 10 VC minus 10 VD plus 10 VC equal to 0. Now sum up VD and VC. 5 VC, 10, 20, 25 VC, 25 VC minus 10 VD minus 500 equal to how much? 0. Let it be equation 1. Now, apply KCL at node D. Then tell me VD minus, here is the potential 100 volt minus 100 by the resistance 5 ohm plus VD minus VC by 5 plus VD minus 0 by the resistance 10 ohm equal to 0. Now also you multiply this one by 50. So 10 times 10 VD 100, that is minus, here is 100. If you multiply it by 10, then it will be 1000 plus 10 VD minus 10 VC plus 5 VD equal to 0. Now you sum up 10, 20, 25 VD minus 10 VC minus 10 VC plus 25 VD minus 1000 equal to 0. Let it be equation 2. If we cancel VD, we can get the value of VC. Therefore, multiply equation 1 by 25. 1 into 25 will be equal to 25 into 25, 625. 625 VC minus 250 VD minus 5 into 25, 125, 100 equal to 0. Let it be equation 3. Let it be equation 3. Now, you multiply equation 2 by 10. Then equation 2 is here. 10 means minus 100 VC plus 250 VD minus 10,000 equal to 0. Let it be equation 4. Now, equation 3 plus 4 will give 625 minus 100 will be 525 VC. This will cancel out. Minus 12,000, 10,000, 22,500 equal to 0. Or VC is equal to, bring this term to the right hand side, that will be 22,500 by 5 to 5, or VC will be equal to, divided by 25, divide both by 25, then this will be 21 and this will be 900. So VC will be equal to 900 by 21 volts. Now let us calculate the potential at D. For that, you multiply equation 1 by 10. That will give 25 into 10, that will be 250 Vc minus 100 Vd minus 5000 equal to 0. Let it be equation 5. Now multiply equation 2 by 25. So equation 2 into 25 will be equal to minus 250 Vc. 25 into 25 plus 625 Vd. 1000 into 25 will be 25,000 equal to 0. Let it be equation 6. Now add 5 and 6. Equation 5 plus 6 will give, this will cancel out, 625 minus 100 will be 525 Vd minus 25 plus 5, 30,000 equal to 0, or 525 Vd is equal to 30,000. Therefore, Vd is equal to 30,000 by 525, which will be equal to 1200 by 21 volts. Now current through this resistor is IC. Therefore IC is equal to Vc minus 0 divided by this 5 ohm. Therefore Vc by 5, that is equal to, what about Vc? Vc is 900 by 21 divided by 5 means into 5, that is equal to 900 by 105 ampere. Then let us calculate ID. ID will be equal to Vd minus 0 by 10 ohm, that will be equal to 1200 by 21 by 10, which will be equal to 1200. 21 into 10 will be 210 ampere. So we calculated Vc, the potential at D, Vd. Now we can calculate the potential difference across this resistor and we can calculate the current. But here I am going to calculate the effective resistance. Therefore, the effective resistance or effective is equal to the applied potential V divided by the total current IC plus ID, which is equal to 100 volts by what is IC? IC is 900 by 105 plus 1200 by 210. So that will be equal to 100 by 900 by 105 plus 1200 by 210 means 600 by 105, which will be equal to 100. You take this 105 here this 900 plus 600 equal to 1500. So 105 by 15 will be equal to 7 ohms. The answer. Our effective is 7 ohms. Thank you. Please subscribe, like and share.